In this video, we're going to talk about how to solve a system of linear equations. A system of equations is where we have more than one equation we want to consider at the same time. And what we're looking for is a solution, a pair of numbers, x comma y, that not only satisfies the first equation, but also satisfies the second. So we need our pair xy to satisfy both of these equations to be considered a solution. So that's what we're going to be looking for. What are these pairs of numbers x comma y? And we're going to look at how to solve this system of equations three different ways. First, we're going to look at the graphing method. Next, we're going to look at the addition method. And finally, we're going to look at the substitution method. So let's begin with the graphing method for solving a system of linear equations. So the first equation, I think we can graph pretty easily just by finding its x and y intercepts. To find the x-intercept, we set y equal to 0. So let's write down this first equation where we've substituted 0 in place of y. And we'll simplify. Divide both sides by -2. And we see x is 6. So when y is 0, x is 6. So therefore, the point 6, 0 is on the graph. So that's this point. Let's see, 1, 2, 3, 4, 5, 6. It's this point right here. That's the x-intercept. To find the y-intercept, we set x equal to 0 and solve for y. All right, we simplify. Divide both sides by -3. Okay, so when x is 0, y is 4. So therefore, the point 0, 4 is on the line. 1, 2, 3, 4. That's this point right here, 0, 4. Now, I know what my line is, right? It's the line that joins these 2 points. So there I've graphed the first line. Now, to get the second line, looking at the x and y intercepts might not be the best approach here because I see I'm going to get fractions. So another way to graph a line is to write it in the form y equals mx plus b. So that means solve for y. So we're going to take the second equation and we're going to solve it for y. So what I'll do is I'll subtract 4x from both sides. Now I'll divide both sides by -3. So I have -4 divided by -3 times x plus 6 divided by -3. Simplifying this stuff, I get 4/3 x minus 2. Okay, so I've written it in the form y equals mx plus b. This is my slope over here, and this is my y-intercept over here. Okay, well, the y-intercept is -2. So it's right here. It's actually the point 0, -2. And my slope is 4/3. So if I go up 1, 2, 3, 4, and over 3, you can see I go here, go again, 1, 2, 3, 4, 1, 2, 3, just like that. I can just keep using that slope to plot more and more points. I can even go -4 over -3, like you saw here, right? That's the same as 4/3. Down 4. And to the left 3, that's a point over here. All right, so drawing a line through those points is the graph of that equation. All right, now what is the solution? Well, the solutions to the first equation are given by this line. The solutions to the second equation are given by this line. So the solution that is for both equations must be where these lines intersect. It looks like it's 1, 2, 3, 4, 1, 2. The point 4, 2, x equals 4, y equals 2 is a solution and the only solution to this system of equations. Okay, next up we're going to look at the addition method. Now, why do we need to look at other methods? Well, sometimes the graphing method isn't so convenient. Sometimes it's not so easy to graph. I was fortunate that I was able to graph this without having to deal with fractions or anything like that. However, you could have, equations that are more difficult to graph. You might have some fractions, in terms of sevenths or things like that are harder to plot. And so maybe the graphing method isn't such a good way to go. So here's a different method. The addition method says that, well, if we have two equations, a equals b and c equals d, then we can add them together and get a plus c equals b plus d. And that should make just intuitive sense. If basket A contained B apples and basket C contained D apples, then if I combine baskets A and C, I should have how many apples? B plus D. So that tells us we can add two equations together. So let's do that here. Well, if I just go down and add these equations together as they are, it's actually not going to be very helpful. But what I'm going to do is I'm going to use a little bit of algebra first to manipulate these equations so that after I add them, I'm going to get something simpler than what I started with. And the algebra that we're going to employ is that we're going to try to arrange that one of these variables cancels out when we add them together. So that means what we want is we want the coefficients in front of the variable to be negatives of one another. If you add a number and it's negative, you get 0. So I see I can arrange that if I multiply the first equation on both sides by 2, because the negative 2 times 2 will become a negative 4. That's the negative of what's in the second equation. And so that will make the x's cancel. So I'm going to take that first equation and multiply it on both sides by 2. And I'm going to leave the second equation alone. It looks like I can get away with just changing the first equation. Now let's go ahead and multiply through the first equation by 2. What do I get? And the second equation? Okay, so I've arranged that these two numbers are opposites. So now what I'm going to do is I'm going to take these two equations and I'm going to add them together. Well, when I add these terms together, I get 0x. When I add these together, I get negative 9y. And when I add these together, I get negative 18. Well, 0x is nothing at all, so I don't even need to write it. Divide both sides by negative 9. And we see that y is equal to 2. So I just got part of my solution. I know that whatever the solution is, the y-coordinate must equal 2. So now we have to get the x part of the solution. Well, how can we do that? Well, we can just go back to either one of these equations and use either one of these to find that. So what I'm going to do is I'm going to take the second equation and just plug in y equals 2. So this is going to be a substitution. All right, so let's take that second equation. But in place of y, I'm going to insert 2, because we know that's what it is. Okay, so let's simplify this. We're solving for x, so let's add 6 to both sides. Oops, we're adding 6 to both sides. Let's divide both sides by 4. And we see x equals 3. Right? Which is the solution that we got right here. So the graphing method and this method produced exactly the same answer. Right? And so this is an alternative approach that you can use to solve a system of equations. And oftentimes this will be a better approach because oftentimes it is difficult to graph equations, especially the ones you find in the real world. Okay, finally we're going to look at the substitution method. The substitution method says what we're going to do is we're going to solve one equation for one variable and substitute it into the other equation and then use that to solve for the other variable. And then we'll proceed from there. So what we're going to do is we're going to start, let's take the easier of the two equations. I think the bottom one looks a little bit simpler to me. And I'm going to solve this one for one of the variables. All right, let's solve this for y. In fact, we already did this when we did the graphing method, remember? So here we had this. We went through and we took that equation and we did solve it for y when we graphed, and this is what we got. Okay, so this is the answer to the first part. We're going to take that second equation, solve for y, right? And we're going to substitute this into the first equation, hence the substitution method, right? So substitute this into the first equation up there. Okay, so what do we get there? Well, in place of y, I'm going to insert this stuff. So I'm going to have negative 2x minus 3 times y, but y is this, equals negative 12. Okay, so in place of y, I put what I solved. Right? So now let's simplify this. Now the 3 is going to distribute. So I'm going to have negative 3 times 4/3 x, and then minus 3 times negative 2. All right? Let's simplify this some more. The 3's cancel here, right? So I just have this, right? And let's see what we can do here. Well, we can combine these like terms. I can subtract 6 from both sides. I can divide both sides by negative 6. And what do we get down here? We get x equals 3. So we found the x coordinate of our solution. Okay, that's part of our solution. How do we get the other part? Well, the same thing we did in the addition method. We're going to take this one and substitute it back into one of the equations and solve for the other variable. Okay, so we're going to substitute again. So the second substitution. So let's just plug it into this equation here. 4x minus 3y equals 6. For x is 3 minus 3y equals 6. I'm substituting this in for x. And let's simplify and see what we get. Okay, let's subtract 12 from both sides. Let's divide both sides by negative 3. Y equals 2. So I see that the solution is 3, 2. So we've done this problem 3 different ways. We've done the graphing method, the addition method, and the substitution method. My favorite of these 3 is the addition method. It tends to be the cleanest. But depending on the problem you're working with, depending on how things are set up at the beginning, it may be that one of the other methods are better. So it's really a judgment call that you should make when you see the problem at first.